Hello and welcome to AP Calculus Lecture 5.3b, and here we're going to evaluate derivatives of inverse functions. So you should have the 5.3b notes that you can print out from the file section in Teams. So a few facts about derivatives of inverse functions. If f is continuous, then its inverse is continuous. If f is differentiable, then its inverse is differentiable. If f is increasing, its inverse will also be increasing. And conversely, if f is decreasing, its inverse is also decreasing. All right, so evaluating the derivative of an inverse function without knowing the inverse function. Let's say you don't even know what the inverse function is. You can still evaluate its derivative with this formula. I want you to write the formula in this section on your notes. And you'll have to memorize this, but if you want to take the derivative with respect to x of the inverse, it's 1 over f prime, so you have to get the derivative of the original function of the inverse value of x. So what that is the numeric value of the inverse. Okay, so let's take a look at this third bullet, and then I'll work you a couple example problems. So given that reciprocal relationships between f of x and the inverse value. So if f of x is a and the inverse of a is x, right? The input and output values, we talked about that on the previous lecture. The slope of f of x at point x is equal to the reciprocal of the slope of the inverse at point A. So you need to remember there's a reciprocal relationship between f of x and its inverse. All right, reciprocal of the slope. Okay, so let's work these two example problems. So the first one, given that f of x is 2x plus cosine x, and the value of the inverse at pi is pi over 2, find the value of the derivative of the inverse at x equals pi. Okay. So we have that f of x is equal to 2x plus cosine x. And we know that the value of the inverse at pi is equal to pi over 2. So we want to find the value of the derivative at x equals pi. So what we want to find is the derivative of the inverse. So that's f prime, and then you have the minus 1 to indicate the inverse of pi. Okay, that's what we're trying to find. So first, we need to take the derivative. We're going to use this formula. We have to get f prime, so always start just by getting the derivative. All right, that's going to be 2. Derivative of 2x is 2, and derivative of cosine is minus sine x. All right, so the derivative of the inverse at pi is equal to, let's use this formula, 1 over 2 2 minus the sign. All right, we're putting the derivative in at the bottom, 2 minus the sign. And what do we take the sign of? We take the sign of pi over 2. Not the sign of pi. We use the sign, we've been given this value that the inverse value at pi is pi over 2. So that's what we plug in for x. All right, so that's, what's the sign of pi over 2? It's 1, so that's 2 minus 1, 1 over 2 minus 1, which is equal to 1. And that's it. That's all we're trying to find. Okay, let's do the next example. So the next example says, given f of x is x cubed plus 2x minus 1, and the inverse value of 2 at 2 is 1, find the derivative of the inverse, the value of the derivative, at x equals 2. Okay, so let's write what we know again. F of x is equal to x cubed plus 2x minus 1. We know that the value of the derivative, or excuse me, the value of the inverse at 2 is equal to 1. We want to know what is f prime of the inverse at 2. Now we're going to be plugging in 1, right? So first of all, f prime of x would be 3x squared plus 2. So the value, if we want to take the derivative, at 2, we're going to use this formula. It's 1 over 3 times 1. Now don't plug in 2, you're plugging in the output value, 1 squared plus 2, and that's going to be 1/5. So that's all there is to it. It looks fancy, all right? The nomenclature is kind of fancy here, but the procedure's not. Just take the derivative and use the formula. Okay, so the homework would be a worksheet. So this isn't in your book. All right, so let me bring the worksheet into view here. This is what you're going to be doing. And the first couple of questions, not the first couple, you've got a couple of questions on here where you're using the notes, all right? So like number 2 and number 5, you're using the notes. And everything else, we're using the formula and finding a numeric value. All right, so that is it for this lecture, and I will talk to you on the next one.